Hello Internet, my name is Quentin and this is Blondihacks. I'm going to do an install of TouchDRO today, and you might be thinking, haven't you already done that video? And I have. I installed TouchDRO on my lathe, but today I'm going to be doing it on my milling machine, and this is a different type of thing because my milling machine already has a DRO on it. So this video is going to be about converting an existing DRO to TouchDRO, which you might have to do if you've got an older LED style, or maybe you've got an old Bridgeport with a 2-axis, you want to upgrade it, or if you followed my advice and you got the manufacturer to install the scales for you and now you need to get them going. So let's go. Here's all our goodies for today. I'm actually going to be doing two different upgrades. I'm going to be upgrading one of my lathe scales as well, but let's start with the milling machine upgrade from the factory DRO, which is probably why you're here. This is the current TouchDRO unit 3.2, I think. And you can see it's got 4-axis inputs, and it's also got a tachometer input, and that other port supports 2 separate data inputs, a probe and a quill DRO, so you can sum it with your Z-axis if you want. You'll also need some sort of Android tablet. I have this junky old Samsung one that I happen to have, so I'll start with that one. Next, you need to know what the pinouts are for the DRO scales that you have. You would think that such a thing is standardized, and they all use these 9-pin D-sub connectors, so you think, oh, they're all the same, right? No, they are not. There are several random standards for pinouts on DRO scales. They tend to get grouped into a few major categories though, and the TouchDRO website has a chart that shows all the major brands and most of the mystery Chinese ones and what they likely map to. The TouchDRO website, by the way, is a fountain of information on modern digital readouts, so anything you might want to know about them is probably on there. So you can order your TouchDRO with the particular pinouts that you need, or if you aren't sure, or if you already have a TouchDRO unit or you change your scales, you can get these little jumper blocks. And these blocks allow you to remap the pinouts on the port of your existing unit and allow you to change the scales on the fly for whatever you might need in the future. It's a really nice little system. So there's 4 different remapping blocks that you can swap in and out. And again, there's a chart on the website that tells you which block you need for the particular scales that you have, or you can just order it if you know ahead of time what you're going to need. You can order it with those pins correctly set. I've got the Precision Matthews MagExact system, which is a rebrand of the Electronica EMS system. So it has the same pinouts. And so I've looked on the website and it tells me I need option A for all my pinouts. And I'm just verifying I already have option A of these jumper blocks installed. So I'll reassemble that as is. And let's get this thing going, give it a test and see if these work. And the good thing is you don't hurt anything by just trying different options. So if you don't know what your pinouts are, or you can't figure it out, you can actually just try all the different option blocks until it works. So I'll plug in my X-axis first, give that a little test, power up the unit, and I'll pair that in the Bluetooth settings on the tablet. DRO unit shows there. Once that's paired, I can go into the TouchDRO app, and then I got to tell the TouchDRO app that this is a milling machine. I'll switch that to vertical mill, and then tell the TouchDRO app which unit I'm using, because I have 2 in my shop now, and there we go, it's connected. And if you move an axis and the numbers change, then it's reading correctly. The numbers may not be correct because it's not calibrated yet, but if the scale is moving, then it's working. Now I need to mount this in place of the existing factory head unit, so I'll just do that, and there we go. Perfect, installed. That would be funny if that's what I did, right? If I just taped it to the old head unit. I mean, not a monster. Obviously, I zip tied it on top of the old unit. All the scales seem to be working, so that's good news. All the option blocks are correct. And the best part of the TouchDRO is that the 0 buttons work every time, unlike the pretty expensive MagExact unit behind it, where the zeroing buttons work 60% of the time, which is not annoying at all. Look at that, I can zero with reckless abandon all day and it works every time. I actually wanted a larger and non-Samsung tablet for this, so I went to my local electronics store, which has refurbished tablets, and I picked up this several-year-old Lenovo that is very similar to the one on my lathe, and it's working well for TouchDRO. This does mean I need to transfer some settings over to the new one. Now, if you do like an Android data migration, then you don't have to do this, of course. All of the calibrations and everything are stored in the app sandbox. However, I didn't want to do a migration for various reasons on that crappy old tablet. I wanted to start fresh. But the main thing you want to copy over is the calibration settings. And the nice thing about TouchDRO is that you can go in and manually set the step counts for all 3 axes to transfer them over so you don't have to redo the calibration process. It also means you can back up that information by simply writing the numbers down somewhere in case the tablet ever dies for any reason. I also picked up a random cheapo rugged case for it just to add some thickness to it because that makes it easier to mount. For mounting, I found these wall mount brackets that are designed for laptops and tablets, and they're kind of a universal thing, so they're adjustable. With the added thickness of the rugged case, these seem to fit pretty good. So I'll give that a shot. This thing has these kind of feet on it that I think might actually just be like hooks for storage or something when your laptop is hanging on the wall, or for cables. I'm not sure, but I thought I'd try using them as mounting feet and see how that goes. So I took the old head unit off of there, and it's got a nice little platform that I can use to mount the new one. And nope, that is terrible. That is way too wobbly. There's few things in this world as annoying as an object with buttons on it that is wobbly, because every time you touch it, it's going to move and blech. So instead, I got a piece of steel angle, and I'll bolt these brackets to that, and that'll be nice and stiff. The thick angle is nice and stiff and also allows me to tap directly into it, so I don't have to fuss around with lots of nuts and washers and whatnot. And that seems to work quite well. That was easy to do, and all of the parts I showed here were really cheap from whatever random garbage online places. With that done, let's go over to the lathe. I haven't talked about this on my channel yet, but when I did the DRO install on my lathe, the cross-slide scale that I used is like a random magnetic scale, Chinese one off of Ali something. And let me tell you, that scale is hot garbage. It is just riddled with read errors, and I just couldn't trust it. It would skip steps and lose steps over about an inch of travel, and so I kept having to recalibrate it with a micrometer measurement of the part as I was working. And I had kind of gotten used to it, but it's finally driven me sufficiently crazy that it's time to upgrade to a proper scale. This is a branded Electronica scale, a good quality one, made in India, and it should work much better. Although hilariously, still not perfect, the hardware package that they included is completely nonsensical. It's got these sort of clip things that are supposed to be the mounting brackets for the scale, but they don't make any sense. I guess they're supposed to be like toe clamps for these grooves on the sides, but there's only 2 of them, not 4. It makes no sense. And then these other brackets are supposed to be for mounting the head, but they're supposed to be a 26mm hole spacing, and it's actually 20 and doesn't line up with the holes in the head. It's baffling. This whole kit just seems to be the wrong hardware kit for this scale. But at least the cable clamps fit, so that'll save me 15 cents at the hardware store. Let's get the old hot garbage DRO scale off of there. That's the old reed head, and then these terrible plastic clips that we're holding it on to the ends. If you watch the install of this DRO scale and you're wondering if the Robertson wood screw is still installed in the end of one of those clips, the answer is yes. Yes, it is. It was temporary unless it worked, and well, it worked. So here we are. I did check if maybe those old plastic end blocks could be used to mount the new scale, since there's apparently no mounting accoutrement included with the new scale, but no, that's not going to work. However, the scrap of scale that they sent me is longer than I need, so I think I'm just going to drill holes straight through the aluminum extrusion, and I'll cut the magnetic tape shorter to clear the bolt heads. So I'll do a quick check on what the bolt spacing actually is. I forget what I did here, and I'll drill those out on the mill. Now, I'm drilling holes in the center of those 2 positions. However, you're going to see me slot out the holes in a minute. As I said in the TouchDRO install that I did on this lathe, the critical thing with DRO scale installation is that absolutely everything has to be adjustable. You need adjustability for spacing and angle in all 3 dimensions on the scale and the reed head. All of that has to be adjustable because you have to be able to get everything within 1,000th and within 1 degree of angle and travel in every dimension. This is especially true if you're installing on an older Art Deco style machine like an Atlas or a Logan or a Bridgeport where all of the castings are curved. Boy, installing DRO scales on those machines can be a real engineering challenge because there's no flat surfaces and nothing is square. So adjustability even more important there. So with those slotted out as much as I have room for, better to have too much adjustment than not enough. I should be able to get that straight. And then, of course, you can always use shims as well if you need to get a particular dimension adjusted. In my case, I have other ways of doing that, as you'll see. Now I'm checking the reed head travel to make sure, because this reed head is actually a little wider than the old one was, and making sure I've got enough room for the bolt heads to clear. And you can't see because my hand's blocking the shot, but I'm measuring the height because this head needs to be a little bit lower. So I need to mill a little bit off of my mounting block. Now I'm going to do a mock-up with the scale and the adhesive stainless steel protection strip that goes on top of it. And I want to make sure that I'm going to have enough in-out adjustment. So that plastic shim sets the spacing of the head to the scale. And I'm going to transfer punch these mounting holes in the head to my block. And I'm going to have to do some more modifications to that block. Of course, the mounting holes didn't line up the same as on the old head. I wasn't going to be that lucky. But more importantly, the mounting holes on the old reed head were slotted. So that gave me the angle and in-out adjustment for the head itself. On this one, they are threaded mounting holes. So what I'm going to do is slot out the holes in my mounting block. And that's going to give me my in-out and angle adjustment for the head. The other kind of dirty thing that you'll see me doing here is, because the mounting holes in the head are threaded, really it would have to be bolted from underneath, and there's no practical way for me to do that with this installation. So I'm using smaller bolts and treating those threaded holes in the head as clearance holes. Not very elegant, but it's necessary. So after slotting out the mounting holes, of course I also have to slot out the counterbores at the top. I just connected them into one giant counterbore slot because there wasn't room to do anything else. Not the most elegant modification I've ever done. Why am I saying elegant so much? But it will work. Then those transfer punches that I did can be drilled and tapped out now. These don't have to be insanely accurate because, again, everything is adjustable all around the reed head. All the more reason to make everything adjustable so that your workmanship in all of the mounting hardware doesn't have to be so accurate. Transfer punching and eyeballing things is close enough if everything is adjustable. There's something that makes me feel a little dirty about treating a threaded hole as a clearance hole with an undersized bolt, but well, that'll be a secret between you, me, and 50,000 of our closest friends who might actually watch this. I'm ready to do some testing now, but the new scale has a different pinout than the old one, so I'll swap out the X-axis jumper block for one that matches the pinout of the new scale. Again, you can buy these jumper blocks on the website if you need to, or just order your TouchDRO with the ones that you need. Before I get too serious about anything, I will do a little test and make sure that the scales are reading correctly and there's nothing crazy happening. And sure enough, scales are moving. I'm just sliding the reed head by hand over the magnetic tape and checking that the numbers move, and they do. I'll pause here and call out something important about these magnetic scales. You see that this one has this bar pattern sticker on it, and that's telling you which half of the scale is the measurement half. Some of these more sophisticated modern scales have 2 tracks on them. In this orientation, the lower track is the measurement scale and the upper track is a reference scale. I'll talk more about that in a second. The reed head has the same symbol on it on one side, so you have to make sure that if you've got the bars on the bottom track, then the reed head has to be mounted with the symbol on the lower side. In my case, that's what I did because I needed the head to be mounted upside down so that the cable came out in the more desirable direction, if that makes sense. I'm setting up to cut the scale to length now, so I'll do a temporary mock-up with the head. The light looks orange there. It's actually flashing green and orange really fast, and that tells you that the head cannot see the tape. So as I get it clamped down and slide it in, it'll turn green, and that means it can see the tape. So that's approximately the right place for it. We'll get this set precisely later, but this is good enough for me to do some testing. Now you'll see as I move the head forward, it'll go from green to orange at a random point on the tape. That's one of those reference marks that I talked about. Now I'll put a scale on here so you can see what happens. As I keep going, it turns green again, and then 50 millimeters later, it turns orange again. So there's reference marks on the upper track that are 50 millimeters apart. And you want to cut your scale such that at one end of the slide, the head is going to end up between 2 of those reference marks. This is kind of an optional thing, but what it does is it gives you a hard 0 on the scale. And again, this is a little bit of a more modern thing that mostly matters for CNC machines, but can be useful on manual machines as well. What that hard zero does is it acts like the home switches on a 3D printer gantry or any other kind of computer-controlled moving object. There's always going to be a limit switch at one end, and the computer does a little homing procedure where it finds that limit switch, and then it knows where absolute zero is within its range of motion, and it can count steps from there and know where it is. You can do the same thing with DRO scales. Where this is useful is if you have dedicated tool holders for all of your tooling and they're numbered and you have tool offsets programmed into your DRO, like you would with a CNC machine with a tool changer. And what that does is allows the DRO to know without having to touch off or measure anything where the end of every tool is. So if you're cutting to a specific dimension, you can tell the DRO, I'm using this tool, move it to that position on X and take a cut, and it will cut accurately at that dimension. I mean, you know, within the mockery of physics, of course, there's deflection and there's heat and there's tool wear and things are going to mess with that, but it'll be a pretty close cut. That's not what you see me doing on my channel. I work in a little more old-fashioned way. I either touch off my tools on machined surfaces and zero them, or I'll take test cuts, measure with a micrometer, and program the dimension into the DRO and sort of calibrate it on the fly as I go. I just like working that way. I don't use tool offsets and all of that business, but if you are interested in doing that, this hard zero allows you to do that, and I'm doing it just because, you know, it leaves the option open for me to do that in the future. I have to cut the scale anyway, so might as well cut it here. For the actual cutting, the stainless steel backer on the tape is very hard, and it was immune to all of my snips, so what I found worked was cutting a groove in it with a triangular file and then snapping the stainless steel part and then cutting through the rubbery magnetic tape with a knife, and that made a nice clean cut. Then I actually had to make 2 cuts on the tape to ensure that that reference zone ended up where I wanted it to. Then, of course, the standard procedure for a DRO scale install, you got to make sure it's running within 1/1000th along the length in all 3 dimensions. In my case, the in-out is adjustable with slotted screws on that aluminum block on the back, and then, of course, the holes are slotted for the up and down measurement. This was all covered in much more detail in my TouchDRO install video on this lathe, so you can go check that out if you want, but of course, since I'm putting a new scale on, I have to do all of this again. I'm ready to install the tape permanently, and I decided to put some drops of super glue on the back of it because honestly, I couldn't figure out what is supposed to keep this tape from moving. It slides into the T-slot that's in that aluminum extrusion, but there's nothing that keeps it from sliding to and fro. I suppose that the end caps that were supposed to come in this kit and didn't maybe do that, but that would also require you to cut the scale to a really accurate length, and I don't know. It doesn't seem like a great system, but there is an adhesive-backed stainless steel protection strip that goes on over top of it, and that protects the magnetic strip from abrasion from the wipers on the reed head, but doesn't do anything to keep the scale from sliding. So, I don't know, super glue, I guess. The instructions made no mention of any of this. The magnetic strip is proud of the extrusion, so the adhesive on the safety strip is not holding it in place in any way. Well. And then I'll use the plastic shim that always comes in these kits to set the reed head to scale distance. And also because the shim is parallel, it acts to set the angle of the head as well, which that needs to be within 1 degree. And I can snug all of that down. And that is looking good. These things are actually fairly tolerant. I think the maximum distance is 1.4 millimeters, so that's actually pretty huge. I'll just run it through its paces and make sure that everything is reading nicely and the little 50 millimeter reference marks are all where I expected them to be. In my case, I set that hard zero with the slide in the full forward position up against a hard stop that is on the front of my cross slide there. The design of this scale is such that the magnetic strip is pretty vulnerable. That stainless steel cover is not really protecting it from anything except the abrasion of the wipers. And there's going to get chips and cutting oil and stuff in there, so I think I'm going to put a cover over the whole thing. I always intended to do that with the other scale, but it was much better protected. The magnetic strip was fully enclosed in the extrusion, so it didn't really ever feel that necessary, but this one is much less skookum. The scale necessarily is proud of the surface of the cross slide, unfortunately. It's just, this is a small lathe and there wasn't room to do anything else with it, so that means I need a spacer to get the cover up above the edge of the scale. I marked and drilled some bolt hole locations. You'll notice that the bolt holes are off center, and that's because they have to hit a narrow web of cast iron that's on the edge of the T-slots in the cross slide. For that reason, I'm also using very small screws to do this. This was all done with some serious precisions to make sure that the threads didn't break through into the sides of the T-slot. To drill and tap those, I'm going to use this tapping block that I made. It's got different holes in it for various small threads. This is great when you need to do tapping in the field, as it were. The way this thing works is the holes are clearance size for the thread in question. So I start by marking the hole with a clearance size drill. The drill guide holds it. Then I go through with the smaller tap drill size to drill the hole, and the dimple created by the clearance drill keeps that centered. Once that's to depth, then I can come in with the tap, which fits closely in the clearance hole size, and tap the hole. The nice thing about using a block like this for tapping is that not only does it keep the thread straight, it tends to keep you from breaking the tap as well. It limits lateral forces because there's a lot more vertical surface supporting the tap, and if you do break the tap, it's generally caused by those lateral forces. It's going to break off in the tapping block at the top surface where the shear forces are, and you can remove the tapping block and pull the broken tap out. For the cover itself, I have this piece of galvanized roof flashing. I think it's like 24 or 26 gauge, something like that. It's thin, which is nice because it's within the sweet spot of the capabilities of this sheet metal machine that I have, which made very short work of making this cover. Fun fact about sheet metal shears, they don't actually cut straight down. They actually cut right to left or left to right, depending, because the blade is tapered. That means you can do a little trick to cut an inside corner with it. By cutting a little bit at a time, you can watch the cut progress across the blade and stop when you get to the end of your line. Then flip it 90 degrees and do the same thing on the other cut. Some shears also let you cut on the end of the blade to do this kind of thing, but in my case I can't. The casting is in the way there. But if you do this very carefully, you can sneak in there and do a nice 90-degree inside cut. And then I can also do one bend in this, which is needed to wrap down around the reed head to protect it from chips and gunk. And now I should be ready to bolt this in place and see if it all works. Some explanation of the specific shape of this cover is probably in order. You'll notice that as the cross slide moves, the reed head actually gets uncovered a little bit for part of the travel, and that was a necessary compromise because something that's extremely important in my humble opinion is carriage to tailstock clearance. I always want to be sure I can bump the tailstock right up against the carriage, so I needed to make the cover short of that. That has a lot of advantages. First of all, on a small lathe like this, when you're working on small parts, being able to snug the carriage up against the tailstock to get a small tool to the end of a small workpiece and start the next cut is very, very important. And you always want that tailstock quill to be as retracted as possible for rigidity, which further limits space. Furthermore, the carriage is a useful end stop for the tailstock. It allows you to have a repeatable hard stop when doing multiple drilling operations. All that to say, I won't make any changes to my lathe that compromise the ability of the tailstock and carriage to snuggle up together like that. So for that same reason, I've had to cut it around the back to clear when the cross slide is fully forward, and that means that there's a little bit less protection for that reed head as the cross slide moves forward. But once again, a necessary compromise, and I'm happy with it. That little bit of overhang on the edge of the slide is going to be sufficient to keep chips and oil from getting down behind that magnetic strip or getting down between the reed head and the strip. I will say that I don't run flood coolant. If I did, I'd want to seal this up better. This would really have to be perfectly waterproof to make sure that flood coolant didn't get in there, but in my humble opinion, flood coolant is completely pointless on a lathe this size and for the kind of work I do, so I'm not going to do that anyway. It's terribly messy and causes corrosion, and it's just a big hassle. I also had to be mindful of access to the slide lock on my cross slide. It's in kind of an awkward place on this lathe, so I can't do anything with the cover that would interfere there. Well, there you have it. 2 styles of digital readout upgrade for my machines, a full TouchDRO conversion on the mill and a scale upgrade over on the lathe. And I showed you how to adapt TouchDRO to both of those scenarios. So hopefully there was something in here that was helpful to you. This was not a sponsored video, by the way. Yuri's a friend of mine, and I just really like his TouchDRO system, and I've really enjoyed using it on my lathe, so I was pretty excited to get it going on my mill, and it's going to unlock some new possibilities for me, such as an electronic touch probe, more sophisticated data management, contour cutting, and more sophisticated bolt pattern features, lots of fun stuff, and it's always getting better because it is just software. Well, thank you very much for watching. Thanks to my patrons for making all of this content happen, and I will see you next time.